Number 1. Given the endpoints of -2, -1, and 8, -1 of the major axis of an ellipse, and a minor axis length of 8, write the equation of the ellipse. Now remember, in order to write the equation of ellipse, you need the center, you need the A value, and you need the B value. Based on the info they gave, what do we know? Oh, it took so long for me to get there for third period. The center is actually the midpoint between those two endpoints, right? Those endpoints are technically our vertices. I was about to spell that wrong. About to spell it wrong again. How do you spell vertices? No, I was right. Vertices. So if we know that the center is the midpoint between those two, how do we find a midpoint? Yes, you're finding the average between those two endpoints. So if I'm finding my center, all I do is take the x values, add them together, and divide by 2. We're taking the average of the x's, and we take the average of the y's to find the middle, the midpoint. Where is the center located? That's it. 3, -1. That's our center. So, just because I like to know what this looks like, I'm just going to go ahead and, oh, I forgot a negative here. I'm just going to go ahead and show you this on a coordinate plane. So we have 3, -1 as our center. We have our vertices being at -2, -1, and 8, -1. So this is our major axis. What else do we know about this thing? The minor axis length is 8. What does that give us? Like, do we just put 8 into our equation? Right. In our equation is the semi-minor axis, which is always your minor axis length divided by 2. So our B value here is 4. Our semi-minor length is 4. So from the center, I'd go up 4, down 4. Don't really need to know those coordinate points. I'm just drawing them real quick. What is the last piece I need? The A. What is A? And how did you get 5? Yeah. So here you can see, okay, the center is at 3, -1. The vertex is at 8, -1. Those are a distance of 5 apart. So our A value is 5. You could also look at the endpoints and see that -2 to 8 is a length of 10. So we have that. We divided by 2 to get our semi-major axis. So, someone want to give me the equation for this ellipse? Yes. X minus 3 squared over 25. The A is under the X plus Y plus 1 squared over 16. And it's always equal to 1. Any questions on how we got that? This is going to pop up on your homework. It's also going to pop up in another place. So make sure you know how to do this. Yes? So all we did, remember, we take our semi-major, our A value, and we square it and put it under either X or Y, depending on if it's a horizontal or a vertical ellipse. So here, because our major axis, that 10, was on the horizontal, that means that the 25 goes under the X value because it's a horizontal ellipse. Then we put the B value under the other one, but we have to square it. So we square 4 and we get 16, and we put it under the Y. Any other questions? Oh, my bag. Oh, Addie. What? Yeah, go ahead. All right. Last one. I swear we're almost done. Now this is a very famous ellipse problem. They love asking this question. Love it. It says, Statuary Hall is an elliptical room in the United States Capitol in Washington, D.C. This is a true fact. This room, sometimes called the Whispering Gallery, is 46 feet wide and 96 feet long, I should say. John Quincy Adams is said to have used the focusing properties of the room to overhear conversations. This is a real room in the Capitol, and what it does is, if you're standing on the foci in this room, exactly where the foci are in this elliptical room, no matter how quietly people whisper around the room, you can hear what they're saying. So John Quincy Adams used this property. The people in the room didn't know, but he would stand on the foci and people were having conversations and he would listen in even though he wasn't supposed to. So, and the room wasn't created by chance. It wasn't just like, oh, let's make an oval room and oh my God, I can hear everyone talking. No. Some mathematician discovered this elliptical property and then built this room. Now, it's asking us to find an equation that models the shape of this room. If geometry taught you nothing, hopefully it taught you that when there is no picture drawn, you draw it. Did geometry teach you that? Hopefully it did. If there's no picture, you draw it. So we're going to go ahead and draw this ellipse. Now, in general, if it's talking about something that has a width and a length, it's assuming that your length is on the horizontal and your width, oh God, that's an awful ellipse, and your width is vertical. This is how Math Excel always assumes it. If it gives you a length and a width, the length is horizontal and the width is vertical. So here, if it's 96 feet long and 46 feet wide, what are those numbers to us? What do they mean? In an ellipse, they tell us the lengths of what? The minor and major axis. Good. Now, do I just put the numbers for the minor and major axis in my equation? What goes into my equation? The semi-major and semi-minor. So here, I'm going to create a center point, and my semi-major axis length is how much? What is that? Close. So close. 48. Good. And what is your semi-minor, your B? 23. Good. Now, for simplicity's sake, when creating this equation, we can choose to have the center point at any coordinate point. Where do you think we should take the coordinate point for the center to be? 0, 0. Always when you're trying to simplify things and you can assume it's anywhere, you should assume the center's on 0, 0. You assume it's on 0, 0 because now you don't have to worry about adding or subtracting anything from your x squared and y squared values. Instead, we just place our a and b values under x and y. What goes under the x squared term? So it's 48 squared, and if we square that, we actually square it, we get 2304. And what goes under the y squared term? Good. 23 squared, which is 529.
Does it matter if the ellipse is horizontal or vertical?
So that's what I was trying to explain. In general, like if I was grading this, no, you'd be 100% correct. However, Math Excel being the picky, you know what it is, Math Excel takes the length as the horizontal and the width as vertical. So if you switch this in Math Excel, it will count you wrong. But in reality, in the real world, you're 100% right. Now, what are ellipses always equal to? 1. And we're done with that equation. We're done with that equation. That's it. Not quite so hard, I hope. Just have to understand what the numbers given to you represent. Now, it also asks for the area of the room. And it so nicely gives you the equation for area of an ellipse. It's just pi times AB. And we learned last class that in higher level math, anytime we have a pi, we need to leave our answer in terms of pi. So we have pi times A, which was 48, times B, which is 23. And we multiply these together, and we get 1104. 1,104. I shouldn't say 04. Pi. And what's our unit? Feet squared. Good. Feet squared. Now, last but not least, the only piece of information we need about this room is where the heck are we going to stand so that we can be eavesdroppers and overhear everybody. Meaning, we need to know where the foci are. The foci. You say foci. The foci. We need to know where the foci are. How, for an ellipse, do we solve for the foci? Good. So you're right. If we're trying to find the coordinate points of the foci, that's what we do. However, because this is just in a room and we want to know where to stand in the room, instead of taking C and adding and subtracting it to get the coordinate point, we're just going to find C and say we need to stand blank distance from the center. That's how we would apply this to real world. Because it's not necessarily on a coordinate plane, right? A room isn't. So, first we're going to solve for C by taking the square root of A squared minus B squared. A was, what was it? Right, it was 48, and then 48 squared was, good. So we have here 2304 minus 529, and what do we get? Yes. And depending on how Math Excel wants our answer, depending on how we want our answer, we're going to have to square root this. We're going to have to simplify this square root. What perfect square should you know goes into this? 25. And I'm going to tell you before we rack our brain, 25 is the biggest perfect square that goes into this. So I'm going to pull out the square root of 25 times, what times 25 is 1,775? Close. Oh, no, you're right. Why was I thinking 81? No, yeah, you're right. 71. So here we have 5 square root 71. Now, they may ask for this as an actual numerical value, as an actual decimal. When you put this in your calculator, we won't ask you to do this on a non-calc, but if we ask for an actual numerical value, we give it to you on the calculator portion, you'd put this into your calculator, and you would get about 42.131. That's how far away from what do we need to stand? Yes, feet away from the center, away from along which axis? Yes, but major axis, we'll say. So because this is a real world situation, we want to know exactly where to stand. We're not going to apply this to a coordinate point, right? If I told John Quincy Adams to stand, where would that be? 5 square root 71 comma 0, he would have no idea what you're talking about. But if you just said stand 42.131 feet away from the center, I mean, I don't know how you could stand 0.131 feet away, but they figured it out. Any questions on these problems? Again, they are going to show up for you on important pieces of paper. 1 and 3.